Welcome to Bite-Size Data Science. Once you've created a model, how do you know if it's good enough to deploy? For this, there are multiple methods available and they depend on the type of algorithms being used. Let's start with some basics. Intuitively, how do you know if a model is worth anything? Let's say we want to predict the flip of a coin. We know that given enough tries, we should get an equal number of heads and tails. By predicting that we always get head, for example, we reach an accuracy of 50%. Any model that does not achieve more than 50% accuracy is not worth using. We can say the same thing about a churn model. If we have a churn of 10%, a model that gives us a 90% accuracy may not be that useful. Let's look at a few things: the training data set, precision, and recall. Staying with our churn example, one thing that can help creating better models is to have a better ratio between the churn and non-churn records. Some experts I know recommended a minimum of churn value of around 30% of the training dataset. Accuracy is not the only way to evaluate a model. Before we get into that, let's look at something called a confusion matrix. In the following matrix, the green squares represent the number of times the model got the prediction right. If we divide the sum of the green squares by the sum of all the squares, we get the accuracy with a value of 98.3% listed in the diagonal. So what are the other percentages we see there? They represent two other measurements, precision and recall. Let's look at the F column first. Precision represents how often we were right in saying that the value was F compared to all the times we said it was F. Looking at the F row, we see what is called recall. It is how often we say that the value was F compared to the total of times we say it was F, and the time we said it was T, but it was really F. The real question is, why do we care about precision and recall? Precision minimizes the number of false positive, and recall minimizes the number of false negative. One often used example is cancer detection. In this case, the right thing to do is to minimize the false negative. This means we want to make sure we don't want to miss any cases. Therefore, we want to maximize recall. There are a few other popular evaluation algorithms available for classification models. One of them is called ROC-AUC, which measures how well a feature can distinguish between two groups. Another one is the F1 score, which uses both precision and recall for its calculation. When it comes to regression type algorithms, the evaluation always centers around a measure of accuracy. This includes scoring such as root mean squared error, mean absolute error, median absolute error, and so on. If you remember linear regression that was discussed as far back as video 3, you can easily understand that it is always a calculation related to the distance of a prediction to its real value. At this point, we're able to evaluate a model, may that be for classification or regression. We now want to make it available to other people or applications. The literature often leaves it as an exercise to the reader after the model is saved to disk. A model requires a runtime environment. For example, languages like Java and Python require runtimes that execute the given bytecode. Then, there are the libraries that were used to create the model. Libraries like scikit-learn, SparkMLlib, XGBoost, TensorFlow, Keras, Caffe, PyTorch, and so on. We can't expect applications to add support to different languages and libraries. The best approach is to keep the model deployed completely separate from any applications and make it available through a web service. In this video, we discussed evaluating our model and then deploying it. Deploying a model is not the end of the process. In some ways, it is the real beginning. We need to monitor the use of the model and its efficacy. This is a subject for another video. See you next time on Bite-Size Data Science, and don't forget to subscribe.